Okay, so we've all got those AI assistants in our code editors now, right? And they're fine, I guess. But if you're a serious developer, someone who basically lives in the command line, you know deep down you need something more. Something that's less of a chat buddy and more of a precision instrument. That's exactly what we're diving into today, this idea of a principled pair programmer.
I mean, just think about it for a second. What if your AI copilot wasn't just a chatbot? What if you had a tool that felt like a direct extension of your own brain? Something that doesn't just get what you want to do, but actually understands the deep-seated engineering principles of why you're doing it. That's a whole different ballgame.
And this slide really nails the difference. On one hand, you've got the conversational partner. You know, the kind of AI that actually adds to your mental workload because you're busy trying to translate your complex thoughts into some clunky English prompt. But on the other side, that's the goal, a cognitive prosthesis. It's a tool that works like a true extension of your own mind. You don't chat with it, you direct it with sharp, precise commands. It's not a conversation, it's a connection. So to really get why this is such a big deal, we got to talk about this hidden tax that every single one of us developers pays every day. And it's called cognitive load. Yeah, think of cognitive load like the RAM in your own head. Every little thing you do as a developer, I'm talking remembering syntax, juggling variables, translating an idea into code, even just figuring out what some tool just did, it all eats up that mental RAM. And the more RAM you waste on the process, the less you have for the actual problem. So the name of the game, really the key to getting into that perfect flow state, is just minimizing that load as much as possible.
And what's really cool is this isn't some newfangled idea. No, this is grounded in decades of research from the absolute legend, Don Norman. He pointed out these two massive gaps that trip us all up. First, there's the gulf of execution. That's the huge gap between the goal you have in your head, like, I need to refactor this function, and all the actual steps and commands you have to type to make it happen. Then you've got the gulf of evaluation. That's the mental effort it takes to look at what the computer did and figure out, okay, is this actually what I wanted? The absolute best tools, they make those gulfs practically vanish.
All right, so let's shift gears and talk about the environment, the arena where a tool like this is really meant to shine. And look, we're not talking about some friendly web UI here. We're talking about the deep end, the high-performance command line world of a pro developer on Windows. We're talking about the WSL2 terminal. And to really work effectively in this space, you've got to understand the architecture. WSL1, the original version, was basically a translation layer. Kind of clever, but limited. WSL2, though, that's a whole different beast. It's a genuine, lightweight virtual machine with a full Linux kernel running inside. And that's the key. That's what gives you that near-native Linux performance. It's an absolute game changer for things like compiling code or spinning up Docker containers.
But, and this is a big but, there's a hidden catch that comes with all that power. It's called the file system boundary problem. Here's the deal. Anytime a Linux tool running inside WSL2 needs to reach out and touch a file on your main Windows drive, you know, the C drive, your performance just falls off a cliff. It gets super slow. So the #1 unbreakable rule for any serious WSL2 dev is simple. For performance, your project files have to live inside the Linux file system. End of story.
And because we're talking about a professional setup, you got to be precise. You don't just go and randomly install Node.js. No, the right way, the architecturally sound way, is to use Node Version Manager, or NVM. This lets you lock in a specific, stable version of Node, which just saves you from a whole world of headaches and compilation errors down the road. Once you've got that solid foundation, then you can do a clean, global install of the Gemini CLI. Seriously, this isn't just a nice-to-have, it's pretty much required for a stable setup. Okay, so we've defined the problem, cognitive load, and we've set the stage, the WSL2 terminal. Now let's finally talk about the tool itself. This thing has been engineered from the ground up to be way, way more than just another chatbot. This quote, this is the whole philosophy in a nutshell. We're talking about a tool for an expert, someone who already knows what needs to get done. An expert developer doesn't need someone to hold their hand. They need a force multiplier, something to make them even better.
So how does it actually bridge those two gulfs we were talking about earlier? Well, for the gulf of execution, it gives you these super clear slash commands, like /refactor. These are what Don Norman would call signifiers. They literally tell you exactly what the tool can do. And across the gulf of evaluation, you get structured feedback every time. A clear explanation of why it's doing something, followed by a simple code diff. There's just zero guesswork.
But here's where things get really, really interesting. This is the secret sauce, what actually makes this AI principle aware. It's not just some clever prompt hidden under the hood. No,
It's a formal, explicit agreement, a contract between you and the AI.
I mean, just pause and think about that. How in the world do you take all the collected wisdom from legendary books like Clean Code or The Pragmatic Programmer and boil it down into something a machine can understand and, more importantly, follow consistently every single time?
Well, you do it with a contract. It's just a simple, human-readable markdown file called Gemini.md, and it lives right there in the root of your project. This one file becomes the single source of truth that dictates every single move the AI makes. So what's actually in this contract? The absolute cornerstones of software craftsmanship. Principles like keep it simple, don't repeat yourself, and the single responsibility principle. And look, these aren't just gentle suggestions for the AI. They are hard-coded directives. They're the rules of the road. The contract even covers the rules of engagement, with clauses like safety first, which forces the AI to always ask for your permission before it changes or overwrites any of your work.
All right, that's enough theory. Let's see how this actually plays out in the real world. This is the payoff, right? This is where all those abstract principles turn into real, concrete action.
So, imagine this. A developer's got this Python file, and it's starting to get a little messy, a little complicated. Now, instead of typing out some long, rambling prompt trying to explain the problem, they just issue one single, powerful command. They're telling the AI to refactor the file, and they're specifically telling it to follow the single responsibility principle that's laid out in its contract.
Okay, now check out the AI's response. This is key. It doesn't just spit a bunch of code back at you. It starts by telling you its reasoning, its rationale. It explicitly says it's following the single responsibility principle. It's showing its work, and it's proving that it understood the intent behind your command, not just the words.
And right after that, it presents the proposed changes as a clean, simple diff. Your job of evaluating it becomes instant. You can see right away how it's taking that one big, clunky function and breaking it down into smaller, focused units. I mean, this just perfectly bridges that gulf of evaluation we talked about.
But honestly, the real magic is what happens after that. First, just like its contract says, it asks for confirmation before it does anything destructive. The user says yes, and then, and this is the cool part, it doesn't just stop and wait for your next command. It thinks ahead. It anticipates your workflow. It proactively suggests the very next logical step, which is to create new tests for the functions it just made. This is what takes it from being just a passive tool to a truly active partner. Now, if you zoom out for a second and think about the long-term impact, a tool like this is about so much more than just making one little task go faster. It's about fundamentally changing the health and the entire future of a project over its lifetime.
You know that feeling of software entropy? We've all seen it. It's basically the broken Windows theory, but for your code. You take one little shortcut, then another. And before you know it, the whole project is slowly degrading. Now, a generic AI, one that's just trained on all the chaotic code on the internet, can actually make this worse. It can pour gasoline on that fire. But an AI that is bound by a strict cognitive contract, that AI becomes a tireless guardian against that decay. It makes sure that every single change respects the project's core principles.
And really, that brings us to the final thought here, and it's a big one. What we're seeing is a shift, a move away from tools that just write code to tools that understand and enforce craftsmanship. So the real question we have to ask ourselves is this: what becomes possible when your AI partner isn't just some powerful code generator, but a true practitioner of the craft? An agent that actually cares about the quality and the future of your work, just as much as you do.